All right, so does she do work on the bearing, getting it ready to shoot? Well, what we have here, work equals force times distance. And we have our ball bearing, and the ball bearing is being pulled backwards. And so basically, we're pulling this way on the ball bearing. There's definitely an applied force. And the applied force is over a distance that's going this way as well. And so we're stretching the elastic band, which is pulling the opposite direction. So the work that's being done right here is by Val herself pulling it back, and also recognizing that the distance is in that same direction as she pulls it back. So when she releases, we'll definitely see that thing fly, and the potential energy will be evident as it gets converted into kinetic energy. So let's go through this. Is there a force? Absolutely, there's the applied force being pulled back there. Is there a distance? Yes, that whatever it is, 20 centimeters or whatever, they pull it back. So there's definitely a distance involved as well. So is there work? Absolutely. And so the question is this work, let's consider, is it positive? Well, the distance and the applied force are both in the exact same direction. Again, in order for work to be happening, we know that they have to be parallel. If they're in the same direction, that means that there's a gain in energy or positive work for the system. If it's a negative, then that means there's a loss of energy due to this work. So in this case, we definitely have a gain. So a gain in, well, it's stretching out that elastic band, so it's definitely a gain in potential energy there. Now, when she releases it, then that potential energy will be converted into kinetic energy. But what we're being asked, and sometimes with these energy ones or work ones, you just have to reread it just to double check that you're answering exactly what's being asked. Did she do work on the bearing, getting it ready to shoot? So that's where the potential energy is, and that's where we see the work.